Hello and welcome back. Today we are talking about common factors, and we're going to talk about how we can use common factors to find the greatest common factor and then the greatest common monomial factor of a polynomial. So, first of all, with common factors, an example that we'll use is 3. 3 is a factor of both 6 and 9. 3 is a common factor for these numbers. So now you know what we're looking for. And let's do a quick problem. Okay, number 1 says find the greatest common factor of 48 and 60. So you will recall that we did prime factorization in the previous lesson. And when we did prime factorization, we had these factor trees. But we basically just did one number at a time. So when you find the greatest common factor of two numbers, you're going to want to do them side by side, or just do them knowing that they're both a part of it. Okay, so let's start with 48. 48, we chose 4 and 12 because 4 times 12 is 48. And 4 can be broken down into 2 times 2. 12 can be broken down into 2 times 6. The 2 is already a prime number, but the 6 is not, so that can be broken down into a 2 and a 3. Okay, so let's look at the number 60. 60 can be broken down into 4 and 15. And keep in mind, if you start with different factors of 60, for example 20 times 3 or any different factors, it doesn't matter, because at the end, when you've broken everything down and you can go no further and you have all prime numbers at the bottom, at the end that will all multiply up to be this number. Okay, so with 60, we're using 4 times 15. 4 can be broken down into 2 times 2, which are both primes, and we can't go any further. 15 can be broken down into 3 times 5, which are both primes, and cannot be broken down any further. If you would like to check, to double check yourself, you could go along and just multiply. 2 times 2 is 4. Times 3 is 12. 12 times 5 is 60. That kind of thing. And you can do it down here too. Just to double check yourself. The very ends of these, the little trees, the little twigs on the end, you can take those, the prime numbers that you get at the end, and multiply them. It should equal the number you started with. Okay, so the question said find the greatest common factor of 48 and 60. Well, we found all the factors. We factored these both down to the smallest primes. So what we can do is simply list those prime numbers from left to right in ascending order. So 60 equaled 2, 2, 3, and 5. 48 equaled 2, another 2, we got another 2, and yet another 2. 4 2s, and the last one we got was a 3. Okay, so are there any common factors? Sure. Let's see if we can pair up some of these, and we'll pair up as many as we can and just ignore the ones that are left over. So from the number 60, this first 2 has a pair down there with the 2 and 48. with the number 60, the second 2 can be paired with another 2 from 48. With the number 60, the 3 can be paired with the 3 from 48. And that's it. There's no match for this 5 here. And these 2 are just left over. These 2 that are left over from the number 48, there's nothing, there are no more 2's in the number 60 to match with them. So basically it's kind of like, and let me get another color to do this. It's kind of like, you can just scratch them out. Okay, so down below we're going to write the common factors from left to right. The common factors from 60 and 48, and those are 2 times 2 times 3. And you can just go ahead and tell what that equals. They equal 12. So the common factors, you remember before when we did our regular prime factorization, we would get the numbers at the bottom and multiply them all together, and they would equal the number at the top. When you do prime factorization, that's it, you're done. You've just factored it out to the primes. But when you're finding the greatest common factor, after you factor the primes, you line them up, and the ones that are common, you can remove those out and write them in ascending order. And what you do when you're done with the common factors is just multiply them together, and that number, that will be your greatest common factor. So the greatest common factor of 48 and 60 equals 12. And this is wonderful because remember when I told you when we were going to do the prime factorization of 60, we were starting with 4 and 15. But there are many ways to start this. You can start with 6 and 10, 1 and 60. You can start with 3 and 20. What do we have down here? 12 and 5? 4. Yes, that's another one, 12 and 5. So when you're doing this in your head, you can think to yourself, oh, okay, let's see, what's the biggest number that can go into both of these? And you can say, well, 12 times 5 is 60, and 12 times 4 is 48, and I don't think there's a bigger number than 12 that goes into both of these, so I'm just going to guess 12. So, but a lot of times when we're doing the guessing, we guess the wrong number. Let's see. I mean, what about the number 4 or something? If you're just starting out, it's very hard to guess. It's very hard to guess. So you could say, well, 4 is a factor and of 48, and 4 is a factor of 60. Is there anything higher? I can't think of anything. And then you write down 4, and it's completely wrong. So when you first start doing these, and I know it can be annoying because I also didn't want to waste the paper doing it, but get a clean sheet of paper and just go ahead and do the factor trees. Because very often you will, after you multiply the common factors, you'll be like, oh, gee, I forgot about 12. I forgot that 12 was also a factor of 60, and it's much larger than the number that I was going to use. So. Okay, and this is a good thing to practice because what we're going to do with greatest common factors is use them with polynomials. So in the next video we're going to discuss factoring the greatest common monomial factor from a polynomial. So stay tuned for that, and thanks for watching as usual, and I'll see you next time.